go ahead and let's get started. First and foremost, what the heck are sequences, right? First things first, what are sequences? So if you want to go ahead and write this down, please do. But it's really important that you understand the why behind things. So here we go. Let me go ahead and let Christian in there. There we go. So a sequence is pretty much a list of numbers. That's it. It's a list of numbers and they follow a pattern. Now, the pattern can be with addition. The pattern can be with subtraction, multiplication, and it could be a mix between those. It could be anything really. This today is all about pattern recognition. Now, let's take a look here. We've got 1, 5, 9, 13, 13, 17, 21, and then a question mark. Everybody, what do you think the next number is going to be? What do you think the next number will be? I see some people saying ASVAB 25. I see y'all. 25, 26, 25. I see the majority of us saying 25, and you are absolutely right. Absolutely right. It's going to be 25. Now, everybody, why is it going to be 25? What is the pattern that we notice here? Right, we're adding 4 here. So if we take a look at this sequence, so this is, again, what today is about. Today's about sequences. It's called arithmetic sequences, but we're going to be looking at sequences overall. So different types and different ways of recognizing patterns. But here, if you look at from 1 to 5, you're adding 4. And here's the thing. If you believe the pattern might go one way, test it out, number to number, term to term, to see if it still fits. Because you ask yourself, how do I go from 1 to 5? That's adding 4. And then if I see, well, does the same thing apply 5 to 9? Yeah. And the thing is, they are all 4 apart. If you add 4 every single time, you see that that's the pattern. And once you confirm the pattern, then you apply it to find that next term. So everybody, do we see the basics here of pattern recognition? Yes or no? Do we see kind of like the basics here of it, where we're reading one term to the other, and we're potentially seeing, hey, how do we go from this one to the next one? How about that one to the next one? This one to the next one. And if that pattern fits, apply it and get your answer. That's what today's about. Now, obviously, this is going to be one of the more fundamental sequences that we'll see for sure. And so get ready. You know, if you think that we're not going to be punching the wall today, we probably are. But we want to make sure we understand the fundamental idea here. We are looking at lists of numbers that follow a pattern. So at this point, I'm going to allow you 8 more seconds to take a screenshot. I'll let you take your screenshot and then we're moving forward. I can't even drink water like that. All right. 3, 2, and 1. Let's go ahead and move forward here. So up next, we're going to go ahead and guide ourselves through a little warm up here. So the question reads 13, 20, 27, 34, blank. What is the missing number in the sequence above? What do you guys think? I like the glasses too. Thank you. Let me go ahead and read some of these comments here. I think I missed somebody here. Joshua, what about the ones that goes back and forth, small to big, big to small? Hey, Joshua, don't worry. I got you, bro. I got you. Today's an introduction to sequences, and then I may do another class, a follow-up, as an advanced class. So, oh, and I got to talk about that too later on in class about next month's schedule. We're making a couple of good changes. So I see a lot of people here saying 41. I'm looking at the chat box. 41 for sure. So 41 is going to be the answer. But again, let's understand why, because we're going to get more complicated as we keep going forward. So it's super important that even though you know it's 41, we know the why. So let's go ahead and take a look at these numbers here. Everybody, 13 to 20. If I do 20 minus 13, what do I get? Right, we get 7. We get 7. We would add 7 to go from 13 to 20. We would add 7 to go from 20 to 27. We would add 7 to go from 27 to 34. And so, because we applied the same rule, add 7, add 7, add 7, and it worked out every single time, we can absolutely say that the next number will follow the same rule. We'll add 7, and everybody, 34 plus 1 is 34 plus 7 is 41. And so there it is. Again, these are some fundamental examples. I know that they get much harder than this, but it's all about starting small. We move our way up to a lot of fun stuff here. So let's take a look at this next one here. I'm going to count to 5, so you can go ahead and take a picture of this if you need to. All right, here we go. Next. So 75, 65, 55. What's the missing number in the sequence above? Hey, Mikhail, it's okay. Take your time. I got you. So everybody, is this an example where we are adding the same number to every term in the sequence? That's right. We're going to be subtracting term to term here. We are subtracting term to term. And so because of that, again, it's about noticing what we do from one to the next and seeing if we can apply that same rule. Now, these are what are called arithmetic sequences. There are things called geometric sequences. There are recursive sequences. There are a bunch of different types of sequences, all right? Bunch of different types. So I want to make sure we name them. I know, Justin, I know. We're going to make sure we name them real quick. That way we understand what they kind of are right after we go over this question here. So everybody, what's the rule? How do I go from 75 to 65? Right, we're going to be subtracting 10, not 5. We're going to be subtracting 10 because 75 minus 10, 65. Now, does that same rule apply if I go from 65 to 55? Is that still true? Yes or no? Absolutely still true. Absolutely. And so because we found that the pattern for the first two terms works, it must work for the next. And so therefore, boom, subtract 10 again, and that'll give us 45, making the answer D. Or excuse me, C, my bad. It's gonna be C. So with that said, as it is right now, yes or no, do you understand that a sequence is a pattern with numbers? Yes or no? I like it. Thanks for the participation, guys. Again, participation is way too important here. Right on. So again, all a sequence is a pattern with numbers here. And so again, let me go ahead and just write out briefly the 3 types of sequences that you can face. And so here they are. So the 3 types of sequences that you can run into. 3 types of sequences, at least for the ASVAB that you find. So what we've been dealing with here today so far, these are what are called arithmetic sequences. All right. These are arithmetic sequences. Arithmetic sequences. And so arithmetic sequences, pretty much what those are, is you're adding or subtracting the same number. So adding or subtracting the same number. That's what's called a common difference. But I'm not going to get into the technicalities of naming everything. I want to make sure I keep everything nice and simple in English. And then again, in a class where we'll build upon this, then I'll get a little more technical. But today, it's really not necessary to get technical. Oftentimes, it's actually confusing before we actually get to the hard stuff. So I don't want to confuse you then. But the second type, geometric sequences. So geometric sequences. Does anybody here look at a geometric sequence and think that we're doing a sequence but with shapes? Is that what people think when you see that? Does anybody here think a sequence with shapes? So we're going to go ahead and tear up that misconception right now. That is not the actual case. A geometric sequence is simply a sequence that is found with multiplication and division. That's it. So arithmetic is addition, subtraction, geometric, multiplication, and division. All right. So that's all a geometric sequence is. Again, we're multiplying or dividing the same number. The same number. And so an example, I'll go ahead and give one here. An example would be 2 4, 8, 16, ... So everybody, do we notice here that if we look at the geometric sequence right here, 2, 4, 8, 16, ... notice that we cannot add the same number here. From 2 to 4, that's plus 2. But then 4 to 8, plus 4, then plus 8. And so it's changing. It's not the same. So what's happening here is not that we're adding or subtracting the same number, but we are multiplying the same number. Everybody, what's the number that we're multiplying by in that sequence? Cool. I'm glad you guys see it. Yeah, it's going to be multiplying by 2. 2 to 4 times 2. 4 to 8 times 2. 8 to 16 times 2. That is what's called a geometric sequence. A couple of y'all may have also seen examples like this. They could have been showing you an example like, oh, let me let Nancy in real quick. Cool. We may have seen an example like this where it's like, oh, we have, let's go ahead and say 4, 2, 1, 1/2, 1/4, 1/8, ... Anybody ever seen something like that? Bruno, that's the worst. Yeah. So that's also a geometric sequence. But remember, once you understand the fundamentals, you're much more equipped to actually handle stuff like this. Because think about it like this. If you had something that you were really anxious about, something that you were really worried about, doesn't it make it a little easier when you can actually name it, when you can actually identify the pieces of it, identify what's stressing you out? Like, isn't it better overall with your problems? Like when you know how to actually name them and talk about them? I would say, yeah. And so this is part of the process. We have to know what these things are called. That way we can connect the strategies they're in and apply those strategies and have a good time. Here's the third type of sequence, everybody. The third type of sequence is going to be a recursive sequence. So recursive sequences. This is the third type of sequence. Everybody, let's go ahead and ask ourselves real quick. Everybody, what does the word recursive mean? What does it mean? Take a guess here. What does the word recursive mean? And your boy has low blood sugar, so I am going to have to eat a little candy bar here, but keep going. What does recursive mean? Kalia says retrace. Yeah, like building from the last. Yeah, repeating a pattern. Well, it is a pattern for sure. That's what the sequence is. But recursive basically means repeating in a way. But what way is going to blow your mind? So watch this. Let me give you this example here where, let me just actually give you the definition here. The next terms actually, I can give you a better description here. We use previous terms to get the next. That's the best way that I can simplify it for right now. Again, there is a very formal way of writing these things out, but I'm not really trying to do that for y'all. I'm not trying to confuse anybody here. This is a recursive sequence, everybody. If I gave you everybody, what's happening in this sequence? Let's see who can figure that out. What's happening in the sequence? Who can describe it in the chat box? What the heck is happening here? Okay, so Maya says +2. Let's see. Let's ask ourselves. If I add 2, 1 plus 2 is 3. No. It's going by 1, then 2. It's repeating 1, 2, 3. Well, there's no 4 there. Ooh, Hoi N. Yes, right there. So Hoi N says, add the previous number. Correct. Let's take a look here, everybody. So we have these first two numbers. Everybody, what's 1 plus 2? Quick, chat box. What is 1 plus 2? Oh yeah, 1 plus 2 is 3. Okay, everybody. What is 2 plus 3? Oh, 5. Everybody, what's 3 plus 5? Oh, 8. Everybody, what's 5 plus 8? Oh, 13. Hey, everybody, what's 8 plus 13? 21. So this is a recursive sequence. A recursive sequence is a sequence that uses the previous terms to get the next term. That's what a recursive sequence is. Does that make a little more sense now to anybody? Wow, so off. A little bit. It's all good. But yeah, that's what a recursive sequence is. A recursive sequence is a sequence that uses and builds upon the previous terms. So typically with recursive sequences, the first 2 terms are there already. They don't follow a pattern. So typically for a recursive sequence, the first 2 or so terms, they don't follow any pattern at all. But everything that comes next is based off of those first 2 terms. And it keeps going from there. So one more time, I got you, Nate. I got you, man. So one more time, a recursive sequence essentially uses previous terms to get the next. We have these 2 terms right there, and then we build upon it. So in this example, you start with 1 and 2. So start with 1 and 2. And then basically the next term is the sum or the addition of the 2 previous terms. So the rule here, next term is the sum, or again, adding the previous 2 terms. Right there. Exactly. So you would add the 2 terms that came before. In this case, again, this is not the rule for every recursive sequence. With a recursive sequence, you could take the previous 2 numbers and multiply them. With a recursive sequence, you could add the 2 previous terms and then add 1, or you can multiply and then subtract 1. Like there's so many different ways. Like this thing opens up Pandora's box on a level that could make people's heads explode. But on the ASVAB, you don't have to worry about those ridiculous ones. The most you'll have is maybe something with 2 operations where like you multiply the 2 previous terms and then add 1 or 2 or something like that. It's not going to be too crazy. So let me go ahead and zoom out. Again, right here, 3 types of sequences. I'm going to make this bigger so we can all take screenshots here if we'd like to. Right there. My big old head's in the way. I see that. Let me go ahead and make that out of the way. Let me go and break my neck. So go ahead and take a screenshot, everybody. I know it's a little messy, but I will have this nice and ready. So that's right, Sile. Recursive sequences can do any operations. The recursive sequence just bases the next term in some way, shape, or form off of the previous terms. That's it. That's it. Joshua, right there. There's one of the examples. Another one could be with squares. Another one could be with subtracting of squares. Again, they're going to appear. I got you. We may not have too many fractions in this lesson today, but geometric is where you'll see those fractions. All right, so I'm going to give it another 5 seconds here for y'all to go ahead and take a screenshot if you need to. You know, I can't let you take a screenshot with me making a funny face. I got to do it. Got to do it. 2, 1, and time. All right. So with that said, let's go ahead and ask ourselves here. You know, we talked about these regular sequences, like, oh, what's the next term? What's the next term? Anybody ever seen a problem like this? What is the 7th term in the sequence above? All right, so we have 8 yeses and 1 no so far. And this could appear, again, let me just pause real quick here. Yes or no? Has anybody here ever taken a practice test or the actual ASVAB where they didn't see a topic that they were preparing for? So for example, you prepared for geometry, area, perimeter, but then in your version of the test, you didn't see it. Okay, you see all those yeses right there in the chat box. That can happen. this is one of those topics that if they do give you a problem on this, it'll be one question. And so it could be there, could not, just depends on the actual test. And so with that said, my party people, let's go ahead and get to this one here. 6, 11, 16, 21. The question's asking, what is the 7th number in the sequence above? So Mario already came out here and said, hey, the pattern here is +5. Does everybody agree? Is the pattern here +5? It is. I think we can agree on that. We have +5. That works. That works. That works. And so here's the thing about finding additional terms. You got to make sure you're accurate. Now we're looking at this and we're saying, hey, we got 1, 2, 3, 4 terms. So if we kind of draw this out, this is one way we can do it. 5, 6, and 7. That is one way you could do it. That is one way that you could do it. And so if you keep adding 5, let's go ahead and see where that puts us. Add 5. Everybody, 21 plus 5, hit me. 26, correct. Then we add 5 again. What does that bring us? 31. Add 5 again. What does that put us? 36. So what's our answer going to be? Not quite here. Should have been. That's my fault. A little small little mistake. That should have been 36 listed right there. Let me go and change that real quick, everybody. Bop, bop, bop. And fix that right up with a 6. Boom. That's all good, Mikhail. It's all good. That's on me. That's definitely on me. But there we have it. And so that's one way that we can do it. But everybody, would you be comfortable using this strategy? You guys tell me, would you be comfortable using this strategy if I said not what the 7th number was, but what the 117th number was? Would y'all want to do that? A lot of y'all saying, hell no. And you're right. You shouldn't have to do that. And so what I want to teach you here today is how to handle these arithmetic sequences. Again, the ones where you add or subtract the same number. I want to teach you how to handle these in the best way possible. All right. And so the way that we can handle these is by first observing the pattern and then applying that pattern as many times as needed. So everyone, let's go ahead and ask ourselves this. And there's a couple of different ways that we can do this. So allow me to rewrite all of the terms real quick. It's going to take 2 seconds. 6, 11, 16, 21, and that's it. So we want to get to, and I'm going to assume that it's like a big one, right? I'm going to assume that it's a big one, but I'm just going to say the 7th term. Everyone, here's what we want to ask ourselves if we want to do a problem like this. First, remind me, what was the pattern? What was the pattern? Be specific. 5, what do you mean? What? Lay down 5 cards, a draw 4 and Uno. What are you doing? Add 5, right? We add 5 from one term to the next, right? We add 5 from one term to the next. So the rule is going to be adding 5. Okay. So because the rule is adding 5, everybody, do you really need to add 5, add 5, add 5, add 5, add 5, add 5, add 5? Or is there a certain operation that is a shortcut for adding a bunch of times? What operation is the shortcut for adding the same number a bunch of times, everybody? What operation is that? Multiplication. Exactly. Multiplication is the shortcut of repeated addition. Think about it. If I do 5 plus 5 plus 5, that's 5 times 3, right? That's 5 times 3. 5, 10, 15. 5 times 3, 15. Everybody, just got to do a quick comprehension check. Do we understand that multiplication is simply addition repeated? Yes or no? Multiplication is just addition repeated. That's all it is. Cool. So I know that we know this. I know that we know this, but what I want to make sure you understand is how to apply that with these types of problems. So pay attention here real quick. Pay attention. Everybody, which term number is 21? Which term number in the sequence is it? Mikhail says the fourth. Do you all agree that's the fourth? Yeah, it is, right? Because we can say again, first, second, third, and for sure, fourth. So let me highlight that one in green here. And so we said that the rule was adding 5. So everybody, how far do we have from the fourth to the 7th term? How many terms are in between? How many terms do we go from the 4th to the 7th? Right, there are 3 in between. Joshua, real quick, let me ask you again. I got you, man. So Joshua, do you understand that because we're at the 4th term, to get to the 7th term, that's 5, 6, 7. That is 3 more terms to go. Do we understand that? Yes or no, boss? Because don't worry, I'll clear it all up for you. But for right now, cool. Yeah, there are 3 terms in between. So everybody, if there's 3 terms, how many times are we adding 5? We're adding 5 3 more times. So is it safe to say, everybody, yes or no, that we should do 3 terms times 5 each to get plus 15? Do we understand that? Since it's adding 5 every time, and we're adding 5 3 times, that's 5 times 3, which gives us 15. So to make the jump from 21 to the answer, we can go ahead and add 15. Anybody see that there? We can absolutely do that. We can absolutely do that. So we had the 4th term here to do that. Hey, it's all good, Caleb. Hey, I got you. I got you. Again, this is a nice topic here that once we actually get it, it's going to be smooth sailing. So I do want to make sure I take my time and explain it as many different ways as needed. So this is one way to look at it. We noticed the pattern was plus 5, and we said, hey, we have the 4th term. How many do we have to go to get to the 7th? Well, 4 to 7, that's 3, because 7 minus 4 is 3. Again, the 7th term minus the 4th term is 3 terms away. And so because it is 3 terms away, we know we're going to be adding 5, 5, and 5. So 5 3 times, essentially. And so because of that, instead of doing this like a caveman, 5, 5, 5, we can go ahead and just do, hey, 5 times 3 is 15. That's how much more we have to add. Just do it. Just make the leap. It's all good, Mario. I got you. Oh, yeah, it's for sure being recorded, for sure. But yeah, so that's why I don't want to use the technical terms. Like teachers in school want to go like, all right, so you're going to have your common difference. You're going to have your A1 first term. And let me teach. I know how to do it. So let me show you guys another way to do it from the first term, okay? I got y'all. So let me go ahead and move this slightly. Or let me just copy this. 2 seconds, everybody. Let me just go ahead and copy this. That way I can have this nice and neat. And paste. All right, so let me show you all some magic here. So over here, I'm going to erase this real quick, and I'm going to show you how to do it from the very first term. So allow me here, blah, blah, blah. So cool. Let's restart fresh real quick. Sal, I'll get to your question in a moment. I got you. So if I'm looking at this, and let's say I knew the rule was add 5, but let's say I didn't even give you the 2nd term, 3rd term, or 4th term. Like, let's pretend that we didn't even have those. Everybody, you can start from whatever term you want, any term you want, and get this done the right way. Because again, if the pattern is repeated, then it doesn't matter where you start from. If you know what the pattern is, you can start from wherever. Right here, watch this. Everybody, how many terms do I have to go from the 1st term to the 7th term? How many terms is that, everybody? How many terms is that? To go from number 1 to number 7, how many do I have to jump? Yeah, chat box says 6. Absolutely. Watch this. So if I want to go from the 1st term to the 7th term, let me erase that because that looks ugly there. But boom, to the 7th term, that is 6 terms. Everybody, what's happening every time I go from one term to the next? What's happening? Right, we're adding 5 every single time. And because we're adding 5 every single time, and we had to do that 6 times, right there, I'm adding 5 6 times. 6 times 5. That's what we're doing, everybody. That's what we're doing. Plus 5 every time, which means we're doing 6 times 5 equals what, everybody? 30. Yeah. And so 30 is not the answer. 30 is what you're adding to that first term. 30 is what you're adding to jump. So you're jumping 6 terms, but you're jumping 30 numbers. You're jumping 30 numbers. And so to go from 1 to 7th, you're adding 30 numbers. Everybody, 6 plus 30, that's really hard. What is that? Help me out. That's going to be 36. So I saw you guys asked a couple of interesting questions, and I knew you're going to ask them, so I'm ready to answer them. So did anybody here in the beginning possibly think that, oh, if it's the 7th term, why not just do 7 times 5? Did anybody think of that? Did anybody think, like, why aren't we doing 7 times 5? Why is it 6 times 5? Did anybody think that? Because I know a couple of us did, and it's okay to admit it. Completely okay to admit it. Think about it like this, everybody. If you're trying to do 7 times 5, that means that you're jumping 7 terms. We already have the first. We already have the first. Everybody, if I had the first term and I jump 7 terms, which term would we actually end up at? If we start in the first and we jump 7 terms, we would end up at the 8th term. And that's not what we wanted. We wanted the 7th. We wanted the 7th. And so you do have to think about where you are, where you're trying to get to, and what's in between. You absolutely have to think about that. Absolutely. Because if you don't, then you could make the error of picking 41, because that would have been the 8th term. You see why I put D there now? Hey, what's up, Mario? There we go. That's what's up. Hey, Kalia, again, one step at a time, right? One step at a time. These are great questions, everybody. Baticity here. Hey, welcome in. Thanks for coming. I was thinking about adding 5 and so you got the number. Hey, and again, that'll happen. That'll happen. But again, I want to teach you the ways to do it when it's less convenient to do it by hand. When it's less convenient. You got to trust the process. Exactly. So let's go ahead here and let's take this next example. What if we have this one over here and it's saying, hey, what is the 25th number in the sequence above? Okay. So what I want you guys to do, I want to give y'all a minute and a half to try this one out. I want to give y'all a minute and a half to try this one out. Here we go. Let me give you the time here. And remember, everybody, what I said in the beginning. Remember, try every problem out. Just do your best. If you think that doing it by hand is going to get you there, hey, 25 isn't that big of a number. Do it. Do it. If you think it'll work, do it. All right. Any way you want to solve this, I'm going to give you actually 2 minutes here. I'll reset it. I'll give you 2 minutes. Go. Type ready when you're ready, okay? Type ready when you're ready. I'll start you off by giving you the hint in terms of what you're adding every time. So first things first, before we tackle this problem, I got to make sure that you guys understand exactly why we're here. Notice how a lot of our answers are different. Everybody, if a lot of the answers are different, does that mean that a lot of people might have gotten it wrong? Be honest, yes or no? If a lot of people have different answers, does that mean that a lot of people might have gotten it wrong? No, it actually does mean it. It does mean that a lot of people got it wrong. But again, like, we're not here to stroke our egos and feel good about ourselves. We're here to know that we're getting better. That's it. That's what I get for eating something with almonds in it. There we go. And that granola bar gave me COVID. All right, so let's go ahead and get to it here. Woo. 10, 22, 34, 46. What's the pattern, everybody? Go ahead. What is the pattern? Obviously, we saw that it's going to be adding 12. So there we are. We're adding 12 from one to the next. Okay. Did anybody here try to go ahead and go, okay, let's just set it up? So that's 1, 2, 3, 4, 5th, 6th. Did anybody try this out and try to do it to get to the end? Be honest. Did anybody try that out? Okay, so some people did try it and they realized like, oh, no, this is going to take way too long, right? And so that's the thing. We don't want to compromise the time that we have. On the ASVAB, you are timed. We want to make sure we're doing things in the most effective way possible. So the things that we do know here is that the rule is add 12. Okay, so here are a couple of different things that we can do. Everybody, we can go ahead and start from the first term. We can start from the second. We can start from the third, the fourth. It doesn't matter. I'm telling you right now, it doesn't matter. So if I were to start from term number 4 and I want to go all the way to term number 25. If I want to go to the 25th term, everyone, how many terms am I jumping from the 4th to the 25th? How many terms am I jumping? Right. If we wanted to start from the 4th term, and pay attention here, because I'm going to show you how you can start from the 4th term or the 1st term or the 2nd. It doesn't matter. If you know what the pattern is, you can apply it at scale. So if I'm doing 21 terms, how many times am I adding that 12, everybody? How many times am I adding the 12? Thank you, Felicia. 21 times. If I'm jumping 21 terms, or this way for you guys, since you're looking at me, if we're jumping 21 terms, we're adding 12 21 times if we start from here. Yes or no, do we understand that? If we start from the 4th term, that's 21 term jump, which means we're adding 12 21 times. Yes or no, do we understand that? Okay, so let me go ahead and suggest this. If we're adding 21 terms and adding 12 each time, is it safe to say that we're multiplying 21 times 12? Yes or no, everybody? Absolutely. Absolutely. So to figure out what we're adding here, I'm going to do 21 times 12. We'll do that right up here. Nice and easy, and have a good time. So 1 times 2 gives me 2. 2 times 2 gives me 4. Bring the 0. 1 times 1 is 1. 2 times 2 is 2. Or 2 times 1 is 2, excuse me. So from there, here we go. 2, 5, 2. So everybody, is 252 the term here? Is that what it's going to be? Is that what it's going to be? Yes or no? Felicia says no. Ladasa says no. Bruna, Kadeja, iPhone, Laura, Jeff, Maya, Kendra, Kalia. Yep, that's a no. That is a no, no, no. 252 is not what the term is going to be. 252 is what you're adding. You're adding 252 right here. That is the jump. You're adding that on. Oops. You're adding that on to the 46. That's what you're doing. You're jumping 252, which means you're jumping from 46. So to cap it off, 252 plus 46. What do we get here, everybody? 8, 9, 2. The answer is 298. So that's how you can do it from the 4th term. Everybody, what if we were to go ahead and do it from the 1st term? Let's go ahead and just test things out real quick. Let's go ahead and get risky here. What if I wanted to do it from here? Like, what if I'm really that hard-headed? Let's try it out. So here, How many terms am I jumping, everybody? From the 1st to the 25th. How many terms is that? Right? If I wanted to go from there, I'm adding 24 terms. Again, from 1 to 25, that's plus 24. Yeah. But what number are we adding every time? Right. We're adding the 12 every time. So we're adding 12 each time. So for every term, that's 12. The first one, 12. Second one, 12. Third one, 12. And so we're just going to simplify this by multiplying. Instead of trying to figure out what 12 is going to be 24 times, we can simply do this. 24 times 12. I think I got that backwards there. Excuse me. Let me go ahead and do this. 24 and just color coordinate it a little better. Times 12. 4 times 2 is 8. 2 times 2 is 4. Bring the 0. 4 times 1 is 4. 2 times 1 is 2. Add it back. We're going to have 8, 8, 2. And so that right there is what we're going to be adding. That's the jump. The jump from what number, everybody? What are we adding 288 to? What are we adding the 288 to? The 10, because that's where we made the jump from. From the first term to the 25th term is 24 spaces times 12 means we'll make a jump. Jumping by 288, which means to get the answer, boom. If we do 10 plus 288, what do we get, everybody? What do we get? 298. Exactly. Both times we get the same answer. Do we understand that it doesn't matter at all which term you start off at? It is simply about doing it the right way. Yes or no? Are we starting to feel a little more confident with this? And I see someone asking, I did 12 times 25. And so, Laura, that's fine. Hey, that's fine. So Justin and Laura, so if you did 24 or 12 times 25, again, what that means is you jumped 25 terms. Think about it like this. If I jumped 25 from the first one, 25 plus 1 is 26. You would end up at the 26th term, which would have gotten you 310. That would have gotten you D. So Justin and Laura, do you see why it should have been 24, not 25? You're not multiplying by the term number. You're multiplying by how many it's going to take to get there. We're multiplying by what it's going to take to get there, not the actual number. So that's the framework we're going to operate out of. All right. That is the framework we're going to operate out of. So Pedro, I got you, boss. Yeah, so great question there. So Pedro asks, where did I get that 21 from over here? So if we started from the fourth term, Pedro, everybody, what's 25 minus 4? What's that jump going to be there? Remind me again. 21. So Pedro, that's where I got the 21 from. Because if you go from fourth term to 25th term, that's 21 term jump. So 21 terms is how many we're jumping by. 12 times every time. 24 times 12. Cool. I got you, boss. So again, these are arithmetic ones, okay? These are arithmetic ones. And so, hey, Karen, again, it's all good. And Hoy, yes. Let me know if I'm pronouncing that correctly, if it's Hoy. But will this work will this only work if it's adding? What about multiplication or subtracting? So my answer to that is this works for adding and subtracting. This works for arithmetic sequences. So there's a formula that actually I can teach you, but I don't give a damn about the formula because every time I show a formula, people want to just memorize the formula and think that they're safe. It is not about memorizing the formula. It's about understanding how to use it. So what I just did just now in this past half hour, everybody, I literally just taught you the formula for arithmetic sequences, but I didn't show it even one time. But now you know it. And when I present it soon in the next class, you'll know exactly what it is because you'll know what the pieces mean. So I got you. So with that, Alex, hey, reach out to me on the side. I'll give it to you. Reach out to me on the side. So we're going to have time practice here. So remember what I said, everybody. I got to give you two announcements here. One, I'm going to go over every question that we're going to perform today, and I'm going to record myself doing it. While I'm recording the solution to the question, you are perfectly allowed to ask questions. One more time. I am recording these solutions to put them in the math bootcamp for everybody in the all access pass tomorrow. You'll receive these tomorrow morning. You are allowed to ask questions. Please type them into the chat box when you have them, the moment you have them, because I want to basically make these videos as a way of being like, oh, I'm filming this, but I'm getting your questions, the same questions that other people might have at home by themselves. I want to answer those questions in real time. So we're going to work together here to make this the best math bootcamp ever. So I hope you see what I'm saying there. Number two, first thing with number one here, any question that we don't get to by the end of today, I will be filming them tomorrow morning and adding them to math bootcamp tomorrow morning. All right. Now, number two, starting in October, so not this week, but starting next month, everybody that's in the all access pass, we are going to be alternating word knowledge and paragraph comprehension on Wednesdays. So instead of doing 1 hour, I'm going to make a full 2 hours word knowledge, a full 2 hours paragraph comprehension. I sent out the survey last week. You guys overwhelmingly said that idea you love. So we're going to try it out for October and see how it goes. Okay. So let me know if you guys like that. And I do see a couple of people already asking me about the all access pass. Remember, guys, I'm going to be going over that at the end. So stay till the end. If you like what you see, I have a little special deal going on at the end of the class. So ask me about that at the end. So with that said, let's go ahead here. What's going to happen? You're going to have 2.5 minutes per question or per slide, excuse me. I'm going to present 2 questions. So for 2.5 minutes, try one out, try both out, but I want you to try at least one out, okay? One's going to be a little more fundamental. The other one might be a little harder, okay? So let's get ready, man. Let's get ready. I'm trying out these new ideas, man. And this is because of you guys. Again, you guys made this happen. So 2.5 minutes, type ready when you're ready. Do not give away your answer. I will disown you as my child if you do. 3, 2, 1. Let's go. Okay. So this is going to be the first question. This is going to be the second one. So I'm going to go over both of them. So here we go. I'm going to go ahead and start the recording here. Let's go. All right. So let's go ahead and go over this one, gang. What is the next term in the sequence above? So we're checking this out, and we have 32, 38, 44, 50, ... So this is an example of arithmetic sequence. Remember, we have arithmetic, geometric, and recursive. Geometric being multiplying, dividing. Recursive meaning you're using the previous numbers. Arithmetic meaning you're adding or subtracting, the same thing. So in this case, everybody hit me with it. If I'm taking a look at this sequence, if I'm zooming in a little bit, am I adding the same thing every time? And if so, what is it going to be? Look at the chat box now. I see a lot of yeses and a lot of 6s. Yep. We are adding 6 every time. 32 plus 6. That's going to get us to 38. 38 plus 6. That's going to get us to 44, and et cetera, et cetera, et cetera. We'll follow the same pattern, follow the same pattern. So if we want the next term, we simply add 6 again, giving us 56. And so this first one here, nice, sweet, and simple, to the point, but it's a great example of an arithmetic sequence that allows us to kind of feed into the next problem coming up. And so we'll see you in the next one. Boom. So there's that first one. Appreciate y'all. Appreciate y'all. So now we're going to get into the second one here, where it's going to be asking for the 10th. So let me record again. All right, welcome back, gang. So we have this one, which again builds off of the previous one, but we have what is the 10th term of the sequence above? So this one is arguably going to be a little harder than the last one, because the last one we just had to go ahead and find the next term, but now we have to look a little further ahead now, right? So in order to do this, we still need to recognize the pattern. So everybody, what is the pattern going to be here? What is the pattern still? That's right, plus 6, plus 6. We're adding 6 to every term. So let me go ahead and relist the sequence, because what we're going to do now is we're going to make our plan. We have 32 as the first term, 38 is the second, 44 as the third, 50 as the fourth. So everybody, first, second, third, yada, yada. Everybody, do we have to start from the first term if we want to make the jump? Do we have to go with the fourth term? Right, we don't have to. Remember, as long as we know the rule, we just need to make sure that we're applying it the right way wherever we start, wherever we decide to start. So let me just ask you this before I continue, though. Is it an option to just go 5, 6, 7, 8, 9, 10? Is that an option? Yes, it absolutely is an option. But everybody, why is it not the best option? Why is it not? Longer, takes too much time. There is a faster way. Exactly. Yep, we can absolutely keep adding 6 to our heart's content and do our thing. We absolutely could, but that's not what we're here to do. We're not here to just know how to do these questions. We're here to dominate the ASVAB, right? So here we are. We're going to go ahead here and take a look. So if I wanted to start from the fourth term to get to that 10th term, everyone, how many terms am I jumping? We are jumping 6 terms, exactly. We are jumping 6 terms. Now, if we're jumping 6 terms and each time we're adding 6, what am I doing with those 2 numbers? Right. If I'm adding 6 each time, we are multiplying. Because think about it. The first time I'm adding 6, second time adding 6, adding 6, adding 6, adding 6, and you continue on. Remember that multiplication is literally just a shortcut for repeated addition. So if I multiply 6 by 6, we get 36. Everybody, is 36 going to be the answer, or is 36 the what? What's that J word I've been using? 36 is the jump. Exactly. We are jumping by 36, which gives us 50 plus 36 equals 86. And B is going to be the answer. But I'm going to go over this one other way here. What if we started with the first term? Again, I'm proving to you here that it doesn't matter what point you start from. It's just about applying the strategy the right way. So everybody, let me go ahead and erase this. If you're watching the recording right now, feel free to rewind to go ahead and get these notes there. Feel free to rewind that. But let's go ahead here. And let's say that we're going from, let me use blue here, the 1st to the 10th. If I'm going from the 1st to the 10th, everybody, how many terms am I jumping? Right, we're jumping by 9 terms, adding 9 terms. And then again, just like the last time, each time we're adding 6. Adding 6 every time. And so because of that, 9 6 times or 6 9 times, either way, that's going to be what, everybody? 54. Exactly. You're multiplying there. 54. And everybody, 54 in this case is considered the what? It's considered the jump here. That's what we're jumping by. So I'm going to add 54 here, which doesn't make things hard at all. We're nice and good. 32 plus 54 still gives us that 86. Nice and easy. And I'm going to do this one more way just to make sure for good measure here. If we accidentally did 10, this is going to happen. Mistakes are going to happen, right? If we ended up accidentally doing 10, so 10 times 6 to get 60, and we added it on, where we would have ended up would have been the 11th term accidentally. Because again, we're adding from the first term. 1 plus 10 is 11. 32 plus 60 is 92. Everybody, if you accidentally jump to the 11th term, how can you get back to the 10th? What could we do? Subtract what? Subtract what, Kendra? Bruna, that's right. Subtract 6. Mikhail, that's right. Kendra, that's right. Yep. We can just subtract 6 because remember, the pattern moving forward was add 6. So if we wanted to go back, we would just subtract 6 and we'd still be just fine. We'd still be just fine. And so with that said, let me cut the recording right there and let me answer some questions here. Yeah, I think it's going pretty smooth so far. I like this. I like this a lot. So Sile, what's your question, man? Let me go ahead and give you the mic. Oh, okay. Coaches saw a question in the practice test that changes the counting terms. Like the first term is a +6 and the second is a +10, then back to +6 again. Is there a strategy we can use for those if we are trying to reach a bigger number? So those are recursive. That is telling me right now that if you're going up and then back down, that is recursive. If you're going positive and negative, that's geometric. And so we're going to go over some of those examples here today. And so again, this strategy right now, this works for arithmetic sequences, okay? This jump strategy, it works for arithmetic sequences. It works for arithmetic only, okay? Arithmetic only. Got to make sure we have that there. Baticity, yeah, go ahead and ask the question. I got you. Go ahead and ask it. I'm more than happy to answer for you. But Sil, let me know if that makes sense. And Baticity, let me go ahead and give you the mic here. Go ahead and grab the mic if you want to, or you can type it out. Either way.
You can hear me?
Yeah.
All right. So for the 50 plus 36, that equals 36, what was that strategy that you do? Because I normally do it from the first term.
Got you. So think about it like this, Baticity, and stay on the mic. That way you can answer me directly. So Baticity, when you said, hey, I'm going from that first term to that 10th term, you saw that it was +9, right?
Yes.
Cool. So if I'm going from the 4th term to the 10th term, what do I add to go from 4 to 10?
6.
Right. And so we had that 6. Let me use purple here. So 6 terms. And that's 6 times, right? Because every time is 6. So yeah. Baticity, 6 times 6 is?
36.
Booyah, right there.
Okay. I'm going to start doing a short version now. Thank you.
Yeah, because when you use those later terms, you do have less of a gap to work with. So that's why it can be advantageous for sure. It just depends on your preference.
All right.
Hey, no worries. All right, so great job, guys. Great job. Thank you guys for entertaining that. Are you guys cool with that, though, if I record it that way? Because I do not want to take away from your experience. So are you guys cool with me recording at the same time? That way I can put those questions in the math bootcamp. Okay, cool. So the only thing that for future classes, I might have to take off the ASVAB shirt. Only reason being, those of you guys that are in my classes, you know what my plans are for the future. I'm expanding this. This is going to be a full company, full corporation enterprise kind of thing. And so we're going to be expanding to teaching teachers. I used to teach teachers, so I'm going back to that. But I'm not going to do live classes for them. I'm only going to do like bootcamp courses where they can log in and practice. But ASVAB, y'all are all mine. But I will possibly have to change my shirt to like a regular polo. That way they don't see ASVAB there and they're like, huh? So that's the only thing. But I'm glad that we could test this out. So next things up, everybody, we got 2 more questions coming up. 2.5 minutes. Here we go. Remember, everybody, try one, try both, but I just want you to try. All right. 3, 2, 1. Let's go. Check your work. Make sure to check your work. So allow me to go ahead. I'm going to go ahead and record this one. Remember, I'm going to switch back into Zoom and I'm going to have you guys ask questions if you need to. We're going to have a lot of questions here and I expect you to ask. Here we go. All right, here we go. So we have the sequence here and the problem reads, what is the next term in the sequence above? All right, cool. So obviously we're looking at this and that's a sequence question. The only question is, well, what's the pattern and how do we get to the next term, right? So when we take a look here, we have 5, -2, -9, -16. You may be looking at this saying, hey, negative numbers, no bueno, I don't like it. But let's ask ourselves, how do we go from 5 to -2, everybody? What can we do to 5 to get to -2? Okay, so I see 2 different answers here, but they're essentially the same thing. One way, I see a lot of people saying subtract 7. That's correct. I see a couple of other people saying add a -7. Everybody, is that also correct? Yes, it is. Yes. Subtracting 7 and adding a -7 both mean the same thing. Both mean the same thing. So for the sake of being consistent, I'm just going to go ahead and do -7. But just for your reference, again, those are both the same. So we're going at this and we need to see if that pattern still applies in the same way. So this is where, again, that idea of negative numbers might freak some people out, but I got your back. So to the next term, you may be looking at this saying, hey, how do you subtract from a negative? So think of it like this, everybody. If I'm spending, which is considered kind of a negative thing, if I'm spending and I spend more, well, yeah, you're just spending more. So if I spent $2 and then I spent $3, true or false, everybody, I just spent -5. True or false there? If I spent $2, spent $3, together, that's spending $5. Yeah, same stuff. Same stuff. So everybody, if I spent $2 and I spend $7 more, does that mean that I spent $9? Is that what that means? If I already spent $2, spend 7 more, I spent 9, right? Yeah. Let's see if that continues. If I already spent $9, so -9, and I spend another 7, everybody is -9 minus 7. Is that going to be a -7, a -16? Absolutely. So the pattern holds. The pattern holds here. And so to find the next term, we're going to spend $7 again. So to spend $7 again, everybody, from 16, spend another 7, where are we at? Right, -23. And that's why B is going to be the answer. That's why B is going to be the answer. So my recommendation here is if you're looking at this and you're saying, hey, this kind of threw me off, again, it's probably one of two reasons. One, you're not comfortable with dealing with subtraction with sequences. Two, you're not comfortable with negative numbers. And so with those two together, that can present a big issue. And so I do absolutely recommend that you go ahead and practice that on the side. That way you can come back to this and feel a lot more confident. And so with that, I'll see you in the next one. All right, so with that one, boom. Yeah, and so great question. Let me answer some of these questions here. I got you. So how do we go from -5, or how do we go from 5 to -2? So again, this is all about knowing how to deal with negatives. So just a quick observation here, and then we're moving forward. Think of it like this. If I have 5 and then I take away 7, two things here. One way to think about it is when you are subtracting like this, a positive and a negative, if you're subtracting, you're literally taking the difference. Everybody, how far apart are 5 and 7? Go. Right, they're 2 apart. 5 and 7 are 2 numbers away. Remember, the subtracting is taking the difference. So 5 and 7 are 2 numbers away. But it's going to be a -2 because you're subtracting more than what you have. If it was 7 minus 5, +2. 5 minus 7, -2. That's one way to think about it. The other way to think about it is, hey, if I have 5 and I take away 7, well, true or false, everybody? Taking away 7 is the same thing as taking away 5, then taking away 2. Yes or no? Quick. Taking away 7 is the same as taking away 5, then taking away 2. Cool. So if taking away 7 is the same as taking away 5, then 2, look at this. That right there is going to be 0. -2 is -2. That's another way to think about it. That's just another way to think about it. Okay? Just another way. Now, again, I'm not going to stick around here and, give you a full lesson on negative numbers. That's not what I'm here for. What I am here for is to teach you the concepts here to be more confident and then address how you can practice those little nuances that you need to get better at. So we're going to get into this next one here. Let me record this. And remember, ask questions, especially with this one here if you need to. So moving forward here, we have this next one coming up, and it says, what is the 15th term in the sequence above? Okay, so what is the 15th term of the sequence above? Just make sure every time, no matter what the question is, you know what the objective is, the 15th term. If I'm writing everything out, I have 5, -2, -9, -16, and we're trying to get to the 15th term. So this is the first, second, third, fourth, and then here is the 15th. So just like one of those previous ones, everybody, are we allowed to just go ahead and keep addressing the pattern or keep applying the pattern? Because we saw that it's going to be -7, -7, -7. Could we literally just go -7, -7, -7, -7, -7 if we wanted to? Right, we could, but that's not advantageous. It's not because we want to kill all that time. We want to make sure we condense it to doing this problem in 30, 40 seconds as opposed to 2.5 minutes. So we're going to be, yep, jump gang. That's right, Mikhail. Let's go ahead here. So let's go ahead and pick right here. From the 4th to the 15th, everybody, how many terms are we jumping? Right, we're jumping 11 terms. From 4 to 15, 15 minus 4 is 11. So we're jumping 11 terms. And remind me, everybody, what's happening every time again? Like, what is the pattern every time we go one term? What are we doing? Right, we're subtracting 7 every time. Subtracting 7 every time. And so because of that, what we need to do here is -7 11 times, which is going to give us what, everybody? -7 11 times. That's going to give us -77. So basically, this is what, again, what do we call that again? The -77, is that the answer or is that the what? That's the jump. That's right, Felicia. Yeah, that right there is considered the jump. So what we're doing from -16, let me just circle the whole negative there. From -16 to the answer, we are subtracting 77. Now, here's the great thing. Here's why you shouldn't be super, super worried about this one. The reason you shouldn't be super worried is because if you're already negative and you're subtracting, you're just getting more negative. You're just getting more negative. So all you need to do really here, add 16 and 77 together and keep it negative. Again, this is part of dealing with negative numbers. It is your responsibility to practice this. But again, if you're already negative and you're getting more negative, just add the numbers and keep it negative. So here, 77 plus 16, boom, 3, carry the 1, 8, 9. That is 93. But again, we keep it negative. -93 is the answer. And that is D right there. And so suppose we did it the other way. Suppose we started with the first term. Suppose we started right there. Everybody, how many terms are we going from the 1st to the 15th if we did it that way? That would be 14 in that case. Absolutely. So if we wanted to go the long route, that's fine. We can still do it. We can absolutely still do it. It would go from here to there. That would be 14 terms. And then from here, that means we would do -7 14 times. And we'll still get the same answer. So here, 14 times 7, 4 times 7 is 28. 1 times 7 is 7. Add the 2, that's 9. That is -98. So from here, what we're saying is from 5 to the answer, we will subtract 98. So remember, everybody, subtraction is just taking the difference. Everybody, how far apart are 5 and 98? I love it there. How far apart are 5 and 98, everybody? How far apart are 5 and 98? That's going to be 93. And that's going to be 93, exactly. And so if you get 93, it's going to be a -93 because the 98 is bigger. So we still get the same exact answer. Same exact answer. And so either way, you can still get it. There it is, my party people. D is the answer. And now we can move forward with a little more confidence. All right, cool. So there it is right there. It is 7:35. Let's keep it going, my party people. Everybody, on a scale of 1 to 10, where is your confidence right now? With 10 being like, yo, I can handle every arithmetic sequence in the world. With a 5 being like, yo, I still need my notes, but I'm getting there. A 1 being, I should not even be here anymore because I still am so confused. And be honest, again, you're not hurting my feelings. I need to know where you're at. And again, the person that's privately messaging me, again, I'm going to talk about the all access pass at the end. I know you guys like it so far. I get it. But I got you. Just wait till the end. We got about 20 minutes here. Perfect. Sounds good. So let's go ahead and jump right into the next one. Let's not waste any more time here. We got this. Great job, guys. Great job so far. 3, 2, 1. Let's keep it going. I'm going to look at the chat box now. All right, so let's go ahead and try this one out. What are the missing terms in the sequence above? So this one's a little unique, right? We're looking at this one, we're saying, okay, maybe up to this point, we haven't dealt with problems that had a missing term in there. Okay. But either way, this is still doable, still absolutely doable. So if you're looking at this, I'm going to zoom in just a little bit there. Okay. Is there any pattern at all that we can potentially try to recognize here, everybody? Any pattern at all? Is there a pattern that we might be able to notice? By 2, add 2 goes by 2. Okay, so we can see that there is potentially a pattern here by 2. So let's see if that pattern applies if we were to go ahead and try to fill in those gaps. So everybody, does it work like this? 30 to 34 plus 2. Is that how it works? No, not how it works. We have to go through each term in the sequence for sure. So let's see if the pattern works from 30 to this one here. If I add 2, 30 plus 2, easiest question of the day, we get 32. But the question really is, if I add 2 again, does that get me to 34, everybody? Does that get me to 34? Ah, it does. It does. It does. It does. So we know that, yes, that's going to work out. 32 will be one of those numbers. Now, this is what might confuse some people in the sense of working backwards. So if I'm going from the second term here, if I want to go from the second term to the first term, everyone, what should I do if I'm going backwards now? Oh, I love it. You guys are on it. Yeah. Instead of adding 2 to go forward, we'll subtract 2 to go backwards. And so with that said, boom, to go backwards, we'll subtract 2. Everybody, 28 minus 2, that's going to give me 26. Boom. And so we have the answers being 26 and 32, making the answer here A. Boom. So how are we feeling about that one? A, that's what's up. All right, cool. So we're looking at that first one like, yeah, that's great, man. But help me take care of Godzilla over here, right? We're taking a look at it like, yeah, this is the one that you're like, no. So couldn't you just plug in? Yeah, Baticity for sure. That wasn't the point of the question though, but yeah, you're absolutely right. You can take a quick shortcut, plug them in, see if they work, and you're good. But remember, these classes are not about like, finding the way to get it done. It's about finding the most effective way. And the most effective way for me is always having a reason why you're doing what you're doing. If you're plugging stuff in, it kind of shows, even though you can do it on the test, it does show that you're kind of hoping for the best. So with that, let's go ahead and try this one out here. It's all good, Felicia. Yeah, I can bet you right now like 4 or 5 people did that. Like, it's all good. But here, we got another one here. So let me go ahead and record now. All right, so we're looking at this one. And no matter what, everybody, I don't care how long a question is, everybody, what do I always say? We always gotta do what first in a word problem? That's right, Bruno. Read the question. If you're in my all access pass, you know what I'm talking about. Read the question first. That is always the ideal situation here because you want to know the title of the book before you open it up. I'm not just going to pick up some random book and read about, I don't even know, like, oh, this is what narcolepsy is. No, I don't care about that. So here we are. What is the first term? So in my head, I'm going to go ahead and just boom. First term. There it is. Now, next thing I'm going to do after reading the question is I'm going to gather the important information. Like what up here is important enough for me to actually write down. Let's go. So grabbing the highlighter here. The third term of a sequence is 18. Okay. Third term is 18. So I'm going to go ahead and use my black pen here and say, okay, don't know what the first is. Don't know what the second is. But let me remind myself, this is what I'm going for. That's the goal. That's the goal. I don't know what the second term is. I do know what the third term is, apparently. The third term is 18. Okay, that's what I got from there, the highlighter. Then the fifth term is 38. Okay, sounds good. Don't know what the fourth term is. I got the fifth term, and that's going to be 38. Sounds good. Cool. All right. Now, at this point, is anybody looking at this saying, sweet baby Jesus, what are we doing? How are we supposed to get from 18 or 38 to anything? Like, right? And so it's okay. It's okay. Because if this is where you got confused, that's a good thing. Because obviously, if you haven't seen this yet, it's okay. But it's a matter of, okay, how do we present ourselves with different situations, but still come out with a correct answer? Here's how. It reads, if a common number is added to find the next term in the sequence, what is the first term? So that's very important here. A common number is added to find the next term in the sequence. What does that mean? Everybody, that means, and you tell me, is this true or false? If you're adding a common number, it means that you're adding the same thing every time to get from the next term to the next term to the next term. That's what that means right there. Yeah. In purple, a common number being added to find the next term in the sequence means that you're adding the same thing from one to the next to the next. And so here's a shortcut method, everybody. And if this makes sense but blew your mind, just go ahead and give me a yurt in the chat box. All right. So watch this. Everybody, how do I go from the third to the fifth? How many terms am I adding there? How many terms am I adding to get to the third to the fifth? Or from the third to the fifth? How many terms? How many terms? From term number 3 to term number 5, how many terms did I go up? That's 2 terms. If I go from the third to the fourth, that's 1. And then from the fourth to the fifth, that's 2. 1, 2. I jumped 2 terms. And so what happened there is I jumped 2 terms. And what was the actual jump in terms of 18 to 38, everybody? How do I go from 18 to 38? Right, we add 20 there, right? We added 20. We added 20. So some people here might be thinking, oh, what we can do is we can actually go ahead and take that 20, divide it by 2, and we can get the term for each individual term. We can do that. But I'm telling you right now, you don't have to. You don't have to. Because everybody, how many terms backwards do you have to jump to go from the third to the first? How many terms? How many terms? Yeah. You're going back 2 terms. You're going back 2 terms. Everybody pay attention here. Pay attention. Because if I went up 2 terms and I added 20, what am I going to do if I want to go back 2 terms? Ooh, Maya, Mikhail, Mario, Lizzie. Yes. Subtract 20. One more time. If we go up 2 terms and add 20, if I'm going back 2 terms, I'm subtracting 20. And so with that, my party people, let me go and write this in red here. I'm going to subtract 20 from 18. Everybody, what's 18 minus 20? What is 18 minus 20? -2, because again, 18 and 20 are 2 numbers away, but because the 20 is bigger, you'll keep it as -2, and automatically, the answer is D. So, like I said in the chat box, if that made a lot of sense and surprised you a little bit, give me a yurt. And so with that, I'm also going to show you how to do it the more conventional way. It is a little longer, but I'm going to show you the more conventional way. I got you. So earlier, and remember, the reason I did this is not just to be like, oh, here's a trick. The reason I did this is because remember that on the ASVAB, it's about the quickest way to get it done. That's really what you want. You want the quickest way. Notice how here, I didn't fill in the 4th term, the 2nd term. I didn't fill in any information that I didn't need to fill in. I noticed conveniently that, oh, this is a jump of 2 terms, and I only need to jump back 2 terms to get the answer. And so I just applied the same jump, but backwards. But let's say we didn't see that. What can we also do? what we can do here is let's go ahead and backtrack a little bit. Let me just focus our attention over here. What we could have also done is said, hey, look, if I jump 2 terms and I jumped up 20, well, how do I split that? Because what if I only wanted to know the jump from 1 term to the next? Well, think about it like this, everybody. You can say, hey, I jumped 20 over 2 terms, which is division. If I did a plus 20 over the course of 2 terms, 20 divided by 2, everybody, what is that? 20 divided by 2 is what? Hit me. That's 10, of course. And so, boom, 20 divided by 2 is 10. And so that's the jump per term. If I'm doing 1, so let me erase this here because I'm hoping that you guys already had this down, but you can always rewind or you can always watch the recording to get this back. What I can do is say, hey, if I'm doing 1 term, I'm adding 10. I'm adding 10. Will that still work? Everybody, if I start from 28 to go to 38, will that still work? Yes or no? Will that still work? So yes, it does. If I want to find the common difference, and again, I'm going to get a little technical now, but if I want to find that common number that you're adding by, and you have a gap, basically divide the jump by the gap. Divide the jump by the gap. The jump was 20, the gap was 2. 20 divided by 2 gives you 10, and now we found it. And so what we can do then is apply that same strategy here to work backwards now. And we can say, oh, we'll subtract 10 to get 8, subtract 10 again to get -2. So boom, 2 different ways of doing it. Honestly, there's a few other ways that we can try to do it, one with the formula as well. But either way, we can still get D -2. So with that said, how are we feeling about that one? Feeling a little better? Which way did you prefer, first or second? Let me know. Which way did you prefer, the first or the second way? The first? You like that little shortcut there? Oh, jump 20. Go back. You're good, right? And so again, that's what it's all about at the end of the day, my party people. What it's always been about is, again, having that sense of understanding with the fundamentals to be able to notice convenient situations. This right here was a very convenient problem because the jump forward matched the jump backwards that we had to make. Could have done it right away. Could have done it right away. And so with that said, I appreciate everything. What about pattern recognition? So I do want to see if we can go ahead and do one more here. All right, we will. So what I'm going to do here, everybody, is I'm going to give you one last set of problems. This is going to include some new ideas here, not just arithmetic, but some other ones. I'm going to give you the 2.5 minutes here, but I am not going to explain the answers. I'm going to highlight what the correct answers are, because at the time that we're going to be done, we are going to be at the time to end class. And I do need to make sure that I can help people sign up. One thing I do need to get better at is hopping offline a little closer to dinner time. I got some people that kind of hate me for that. So I'm going to highlight the answer for you, but then look forward to tomorrow morning when I upload the video solutions in the math bootcamp. All right. So with that said, here we go, 2.5 minutes. And again, right after this, if you want to sign up for the all access pass, I got a special discount for you. So just stay to the end. I got you. 3, 2, 1, let's go. For the first one here, the answer will be B, 48. And then with the second one, I'm going to briefly just share with you how you can do it. 1, 2, 3, 4. You're trying to get to number 8. So 5, 6, 7, 8. The pattern here is multiply by 2. Again, this is a quick solution. Quick solution. I know. But notice that to go from one term to the next, you are multiplying by 2. Now you can either multiply by 2, by 2, by 2, by 2, if you want to, or you can do a little shortcut and say, hey, times 2 is times 4, times 8, times 16. So really what we're doing is 24 times 16. And to get that done, that's literally just 24 times 10 plus 24 times 6. So I'm not going to go ahead and try to do mental math. I'm just going to give you the straight up answer. 24 times 16. That's going to be 384. Boom, it's C. So that's a shortcut way to do it. I am going to post a video solution to this tomorrow. So don't worry if you didn't quite get that. I got you, all right? So just to recap again, I saw it was times 2, 2, 2, 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So just multiply by 16 and you're done. That's what it was.